Linux security. In this nugget, we're going to talk about Linux security. Now, we've mentioned security throughout this series when it applied to the topic at hand. For instance, when we were talking about managing user accounts and the Etsy password file, we also talked about shadow passwords, which added an extra level of security to our system. In this nugget, we're going to talk about other security issues that we haven't mentioned so far. First, we'll look at TCP wrappers and directives that we can put into zinetd config files to restrict who can use particular network services on our machine. Then we'll look at setuid root privileges and discuss what security holes result from them. And then finally, we'll talk about IP tables, which gives us another way to specify the kind of network traffic that's allowed on our system. So let's get to work. The first thing that I want to show you with relation to Linux security is how to use TCP wrappers. TCP wrappers are a very simple mechanism that you can use to allow or restrict access to certain services on your system based on the user's domain name or IP address, that sort of thing. Okay, so first, before we go ahead and restrict access to services, I just want to show you and remind you that I've got an FTP server running here on my local Red Hat machine, and if I type FTP with localhost address, then I get prompted for a username, and I could log in, type my password, and gain access to my local FTP server. Okay, now what I want to do is I want to go over to this other window where I'm logged in as root, and I'm up in the Etsy directory, and in the Etsy directory are two files called host.allow and host.deny. These are the two main configuration files for TCP wrappers, and by putting entries into these files, I will be able to allow or restrict access to certain services on my system, like the FTP service that I just showed you is up and running. All right, so let's do something very simple first. Let's just edit the host.deny file. And I'm going to edit it in the simplest way possible. I'm going to say restrict access to all services, followed by a colon, for all users and all domains. So this is saying that every domain out there is denied access to all services because I'm putting the all directive into the host.deny file. Okay, and so host.deny will, there we go, host.deny will contain the entries of the services that, of the domains that are denied access to particular services. So now that I've got that entry into host.deny, if I go back here to my Perry window and I FTP to the local host, then it says service not available, it's been closed. Okay, the FTP server is still up and running, but the fact that I added that entry to host.deny meant that everybody was denied access to that service, even though the service is still out there running and listening on port 21. Now let's talk about this rule that we put into host.deny, this all rule. That said, that's denying all services to all domains. All right. Now let's talk about how to make this a little bit more specific. All right. You don't want to deny all services to all domains on your system. You might want to deny the FTP service to certain domains or a telnet service or something like that. So let's talk about what we would do to host.deny to restrict it in different fashions. Okay, so first let's get rid of the all stuff, and instead let's try to restrict access to the FTP server in particular. All right, so the way that you would do that is you would say pro FTPD is the name of the service, and then you would say colon, and then you could say all there. All right, so this would restrict access to the FTP server from all domains. If you wanted to restrict access to a particular set of IP addresses, like 192.168 dot is the way that you would notate that you want to restrict access to this FTP server from any domain starting with 192.168. That trailing period there is important. If you don't put that, it's not going to match up right. That trailing period says anything else at all after that will match 192.168. Okay? Another way that I could do it is to say .domain.net. All right. Now this says that any server in the .domain.net domain would be restricted from accessing my FTP server. All right. Another key one is you can say local. So it'll say, I'm not disallowing local access to my FTP server. So let's just leave it like that for now and say, okay, we're restricting access to the FTP server from the local machine. And so if I go back now and say FTP 127.0.0.1, you can say see that it says service is not available. So that rule there that we stuck in, the deny rule that we stuck in there, pro FTPD :local, denied access to the FTP server on our local machine. All right, so now you can see how to make more specific restrictions within the directives in the host.allow and host.deny file. Let's just talk for a couple minutes here about how these two files play off each other. What we've done so far is host.allow has been empty, and we've just been sticking rules into host.deny. And the rules that we stick in there will deny access based on the rules that we put in there. Similarly, if we left host.deny empty and we stuck rules in host.allow, those rules would specify what hosts are allowed to access which services that the services that we mention in each of the directives. All right, so they're sort of complementary. If you stick rules or directives into both of these files at the same time, then host.allow will take precedence. So host.allow is always read first. If some rule matches for the particular setting, like the service that you're getting and the domain that you're from, if that's in host.allow, then you're granted access, even if there's a rule in host.deny that will deny you access to that particular service. All right, so the easiest way, I think, is to leave one of them empty and then to fill the other one with the directives that you want, and that makes sure that you're not missing something or overdoing one of your rules in host.deny. All right, so that's how TCP wrappers works on a really basic level. Now let's take these same ideas and look at how we can restrict access to ZynetD services. Now remember, the ZynetD.d directory that lived under the /etc directory contains a whole bunch of files, and each of these files corresponds to some service that ZynetD controls. And we already saw the pro FTP service here because we set this up. And this file that controls access to the pro FTP server that we put on our system. Now let's talk about what we can do here to add extra functionality to this configuration file. And this extra functionality that we're going to add is going to restrict access or allow access in a very similar way to the way that TCP wrappers did it with host.allow and host.deny. Now, the way that TCP wrappers work, though, right, was that we put this, global file out there in the etc directory, host.allow and host.deny, and in that one file, we restricted access to any kind of services that we want, or allowed access to any services that we want. Here, the way that it works with ZynetD is each individual service we can allow or restrict access for that particular service by putting entries into the config file in the ZynetD.d directory for that service. All right, so what can I do here? I can do something like no access, and I can say equals 192.168.1.0/24. So what I'm saying is I'm not allowing access to the FTP service for any IP address that matches this. Now, what is this here exactly? Well, a couple nuggets ago, we were talking about net masks and IP addresses. So the first part of this makes sense, the 192.168.1.0. The /24 is a shorthand net mask notation. So the /24 basically is like a 255.255.255.0 net mask. And what that's saying is that the first 24 bits of the net mask are all ones. And so that's shorthand notation for 255.255.255.0. Okay, so what this is saying is that it's not allowing access to the FTP service from any address that starts with 192.168.1. All right, the sort of the complementary rule to no access is the only from access. And there, what we can say, we can also specify a set of IP addresses, just like that, 192.168.1.24 again, let's use that. But now we're saying we're only allowing access to the FTP service from those IP addresses. So they're complementary rules, the no access and the only from. Another thing that we can do here is we can specify access times So times that we will allow access to happen to this particular service. So I could say something like 08:00 dash 17:00. So only from 8 o'clock a.m. to 5 o'clock p.m. will I allow access to this FTP server. So even if I have both of these directives together and it says I'm only allowing access from these IP addresses, that's fine. If you match that IP address, you will be allowed to access the service as long as you also fall into the access time. So both of those rules have to be met. So if you're trying to access during the access times, but you don't match the IP addresses, you're not allowed in. You have to satisfy both of those rules. So that's a very simple and very similar way to TCP wrappers to allow access or not allow access to particular services that ZynetD runs on a service-by-service basis. So remember that if you want to change something other than the FTP service, you have to go and edit another configuration file to do that. Another important security task is to keep track of the programs on your system that have the SUID root privilege set. Now the SUID root privilege, what it does is it temporarily gives normal users root privileges to accomplish some task. Let's talk about this in a particular case. All right, for instance, when the normal user Perry types the password command, what happens? Well, the normal user Perry would type his password, and then he would also type a new password, okay? And he would retype the new password, and then it says all authentication tokens updated successfully. What just happened? Well, the new password was stored in encrypted fashion in the etc shadow file because we're using shadowed passwords on this system. All right. Now the normal user Perry cannot normally write to the etc shadow file. So what's going on here? How come Perry could make a change to the etc shadow file using this program password? All right. Well, the way that that works is that password has what we call the SUID root privilege set on it. Let's take a look at the password program in detail. And you can see here in this position, in this fourth position, there's an S in that position where normally we would see an X. Well, the reason that there's an S there is because when a normal user executes this program, okay, you can see the execute bits are set for everyone on the system. So when a normal user executes this password program, temporarily they're setting their privilege to being the root user. Okay, so while they're running this program, their privileges are temporarily made to be the root user so that they can write those changes to the etc shadow file. Now, the reason that you have to keep track of programs like this is because, somebody could write a program on your system, give that SUID root privilege to it, okay, and then use that program as sort of a backdoor into your system to gain root access. So they could run some program, maybe temporarily suspend it right when they've been given root access, and then they could wreak havoc on your system. So it's important to keep track of these programs. Okay, programs like the password program are written very well so that it would be hard for someone to gain root access by just typing password. But if someone created their own program and gave it this, this set UID root privilege, then that is a potential backdoor. So it's always good to keep track of all the programs on your system that have this. All right, let's move over to another window here where I'm the root user, and let me just show you how you would find programs on your system that have the set UID root privilege. So the first thing we want to do is find all the files starting in the top level directory that have the user root, okay, and they also have the permissions set, and we're going to check for permissions -4000. By typing -perm -4000, that's looking for the SUID root privilege, or the SUID bit being set, and the user root makes sure that we're talking about, a set UID root privilege. All right, so if I do that on my system and I hit enter, then a whole bunch of files here are going to scroll down, and they're all files like the password program. In fact, there's password program right there, things like crontab or other programs out there that you need root access to accomplish something that this program does, but you only need root access for some temporary amount of time. Okay, so there is all the programs out there. Some Linux systems, I think the Debian system in particular, what it does is every night it runs a cron job that looks for all the programs that have the SUID root privilege. It compares it to the previous day's cron job and see what programs that the previous day found. And if there's any differences, then some mail will be sent to the root user, something like that. I think there's also a log file kept, like var/log/setuid log or something like that. Okay, so that's one way to accomplish that task, is to start a cron job. The command that we just ran right here finds, starting at the top level, root users and permission -4000. We could just make this into a cron job. We could pipe this into /bin/mail. We could put a subject on it like SUID roots, or I think I have to put that in quotes actually, -s SUID root, and then say something, like to root at localhost or something. Okay, so this would mail the root at localhost this file that comes out of the find file. So every morning you could have an email in your system that would show you all the files there. You could also write a little script that does a diff on yesterday's find statement and today's find statement, so you could mimic what that Debian cron job does. Okay, but no matter how you do it, you should do an occasional check for programs that have the SUID root privilege set on them. All right, well, now we've jumped over to my my SUSE Linux machine, and I just want to talk about another piece of software that's available to you to enhance the security of your system. This software is called IP tables, and IP tables is an updated version of IP chains, which was in the Linux 2.2 kernel, and IP chains was an updated version of IP firewall administration or something it was called in the Linux 2.0 kernel. So each major kernel release, they've been enhancing the functionality of this packet filtering software that basically enables you to build a firewall on your system. So you can either, build a firewall like on every workstation, or you can build it on, a station that's acting as like a router to all the other machines in your network. Okay, so let's talk about this just via an example first, and then we'll look at how to generalize this example. Okay, so here's an example that I can show you. So what we're going to do is we're going to ping with one packet -C1, just to make it a fast example here, my local machine. So I do that. It says one packet transmitted, one received. Perfect. Okay. Now what I can do with an IP tables command is I can add a rule to the list of rules that already exists that allows me to just block out certain kinds of packets, like the packets generated by this ping request, for instance. All right, so let me just show you how to do this first as an example, then I said we'll generalize this later. All right, so what I'm going to say is I'm saying add a rule to the list of rules that already exist for the IP tables. And I'm talking about packets that are coming into my system. So you can filter packets, that are going out of your system, that are just sort of passing through your system, and you can also filter packets that are coming into your system. So this ping request here, because I'm pinging my local host, it was generated by my local system. So in some sense, it's going out of my system, but it's also coming into my system, the same request, because I'm pinging my local host. So here I'm talking about input packets, all right? I'm talking about things that have a source address of 127.0.0.1. Let's talk about things that are using the ICMP protocol, and then let's give a directive to this rule to say drop those packets. So anything that has a source address of 127.0.0.1 using the ICMP protocol that's coming into my system, I'm saying drop it. Okay, so I add that rule to my tables. So now that rule is in place. Let's go back and execute that ping command again. I do that, and now it's delaying. Okay, it's basically what it's doing is it's waiting for the timeout to occur to tell me that it failed. All right, it doesn't know that I blocked those packets with this IP tables rule, so it said one packet transmitted, none received. So that packet that I just sent via the ping request to my local machine was blocked, and it was actually dropped. Okay, so that basically just pushed off into Neverland. Okay, now that's how you add a rule to your set of rules via IP tables. To delete a rule, what you can do is instead of using the -A directive, you can use the -D directive, and you have to specify everything else exactly. Now, there's some shortcut versions to deleting rules. You can delete like the 12th rule in the list, or the 17th rule in the list, or the third input rule in the list, all this kind of stuff. This, to me, is the best way to do it, because then it's very clear what rule you're actually deleting. Okay, so here I'm going to say that, and now I can go ahead and ping again, and you can see one transmitted, one received. So that's how you add a rule to your system. That's how you delete a rule with your system with those commands. Now let's talk about some generalizations of the rules that we can put in using the IP tables command. So let's talk about how the packets traverse the filters on your system. So we saw how to make up a simple rule, and that rule is part of a chain. And there's three chains that are in place. There's input chains, output chains, and forward chains. All right. Now, this little diagram just explains how the rules in the different chains are applied and which packets those rules are applied to. It's pretty intuitive. It's actually more intuitive now than it used to be. One thing that you should note is that if you are used to using IP chains, or back in kernel 2.0 IP firewall admin, or whatever it was called, the rules now are a little bit different in how input, forward, and output are applied to the packets. And so, just go by this if you're using IP tables. All right, so basically what happens is there's an incoming packet into your system. All right, that incoming packet has a header. Now that header has a destination address. So there's a routing decision made here by your machine, and if that destination address is your local machine, then it passes on to your local machine, and the input rules are applied to that particular packet. If you have forwarding enabled on your box, and the packet is actually destined for someone else and you're just forwarding it along, then the forward rules are applied to that packet. If you're generating traffic from your local machine, and that network traffic that you're generating is going to go out over the internet, well, on its way out to the internet, the output rules are applied to that packet that you generated from some sort of network program. Okay, so that's the way the three different chains are applied to the packets. And like I said, it's pretty intuitive. Forward rules are applied to forwarding packets, input rules are applied to the packets coming in, and output rules are applied to the packets going out. Okay, now let's talk about filtering specifications, the kinds of things that you can specify with those commands that we typed at the command line in that example a few minutes ago. All right, so we already saw how to specify a source address. We used -s, and we gave some address like 127.0.0.1. Okay, well, we can also specify destination addresses in the same way. You can also use names, domain names for the addresses, like localhost or www.linuxhq.com, and you can specify those for source or destination addresses. So you can filter packets based on where they're coming from or where they're heading to. All right. You can also specify source and destination addresses based on IP addresses, groups of IP addresses. So things like this, 192.195.207.0/24. Remember, that was like a net mask of 255.255.255.0. So that would apply to all addresses, 199.95.207 anything. Okay. So that's other ways that you can specify source and destination addresses. You can also specify inversion. So basically, it's a not. All right, if you're used to any sort of programming, we did this in shell scripting, I think. The exclamation mark represents the not. And so if I said something here like -s exclamation mark space localhost, that would match any packet not coming from a local host. All right. We can also specify protocols. So for protocols, we can specify things like -p, space ICMP, like we did in that example, TCP, UDP, we can specify those. Case doesn't matter, so you can use lowercase or uppercase. And you can also use the inversion operator, that exclamation mark, in the protocol specification as well. So I can say -p, exclamation mark, TCP, to specify packets that are not TCP packets. Okay, we can specify interfaces. All right, so for instance, I can specify the interface as like an ETH0 interface or a PPP interface or something like that. Okay, as a special case, I can put a plus sign after the name, and that will specify everything that starts with PPP. So I could say -I PPP plus, and that would specify all the interfaces that start with PPP. So PPP0, PPP1, etc. Okay, so that's the kinds of filtering that you can do with this. If you need to get more information about IP tables, you should go to netfilter.org, which is this address here, which is where all this documentation is. There's tutorials and other information here in more detail, but I've given you enough information to get you started to do some basic firewall setting for your particular system to enhance the security of your system. One last thing I wanted to point you at before we wrapped up this nugget is I just wanted to show you this website called tripwire.org. Okay, there's also a commercial version of this Tripwire software at tripwire.com, but there is a free version available here at tripwire.org. And basically what Tripwire is it's a program that can check and see if certain software on your system has been tampered with, is basically what it does. Okay, so when you install Tripwire, it goes through your system, it looks at all the different executables and things like that, and it basically creates like a fingerprint for each one of those executables. And then you can run it periodically, and then it can compare sort of the state of the system when you installed Tripwire to the current state of the system now. And if these fingerprints have changed on programs where they shouldn't change, like, you know, executables and things like that, then it will, you know, raise a red flag, and you can check out to see if the software has actually been tampered with or whether you've done an update or something like that. Okay, so that's the kind of stuff that Tripwire does for you. Like I said, right now it's under the general public license, and you know, you can get it for free. There is a commercial version out there at tripwire.com, and this is a highly respected piece of software. A lot of people use it, and it's good for what it does, which is checking to see if certain things on your system have been tampered with. All right, well, it's time to wrap up our last nugget of the series, and this nugget was on Linux security. We started by talking about TCP wrappers. And remember, there's two main config files for TCP wrappers, and they're called host.allow and host.deny in the etc directory. And the rules that we put into host.allow or host.deny will allow or deny access to particular services based on things like IP address, domain name, port number, things like that. Then we talked about directives that we could put in the configuration files in the etc zinetd.d directory. Okay, so the config files that are in that zinetd.d directory control access for one particular service, and the directives that we looked at there were the only from, the no access, and the access time directives. So we can allow or restrict access for certain IP addresses or based on the time of the day, things like that. Then we talked about SUID root privileges. So these are programs that have the special bit set. Instead of it being an execute bit, it's set to an S bit, which means that when you run that particular command, you gain the access of the user who owns that command. And for commands like password and things like that, the root user owns that command. And so when you run the password program, you're actually gaining root access for some small window of time. And programs that have SUID root privileges can be used as backdoors into your system. So it's important that you keep track of all of these files. We talked about how to find files on your system that have these privileges, and you should do that in some regular fashion. Keep track of all the files that have these privileges so you can monitor whether any files have shown up with these privileges that were not placed there by you as the system administrator. And finally, we talked about IP tables, and IP tables is another way that we can restrict access or restrict the kinds of packets and things that come into our system or that leave our system based on the protocol they use or the interface that they use or the source or destination address, those sorts of things. Well, I hope you found this nugget informative, and I hope you found this whole series informative, and thanks for watching.